Our today's lesson is about limits of trigonometric functions. I want to get the limit of sine x over x when x tends to 0. And x is measured in radian, so the angle x is measured in radian. Do it by using the calculator. Adjust your calculator on the radian system. Then take an angle close to 0, like 0.1, okay? So sine 0.1, and this angle is measured in radian over 0.1. And take a value close to 0 more than 0.1, like sine 0.01 divided by 0.01. Remember, the angle is measured in radian. You will find that the function approaches to 1 as x approaches 0. So we have an important rule now, which is limit sine of x divided by x equals 1 when x tends to 0. And to find tan x. And remember, the angle x is measured in radian over x. When x tends to 0, it will be 1. Okay, so sine x over x when x tends to 0 equals 1, and also tan x over x when x tends to 0 equals 1. What about limit 1 minus cosine x over x when x tends to 0? It's 0. And I want to prove it. So we can write 1 minus cosine x over x, then multiply it by the conjugate. The conjugate of 1 minus cosine x, it's 1 plus cosine x. 1 plus cosine x and 1 plus cosine x. So 1 minus cosine x multiplied by 1 times cosine x, it's 1 minus cosine squared x over x multiplied by 1 plus cosine x. As you know, that sine squared x plus cosine squared x equals 1. So 1 minus cosine squared x equals what? Sine squared x. So sine squared x equals 1 minus cosine squared x. So right here, sine to the power of 2x divided by x multiplied by 1 plus cosine x. We can write the numerator as sine x over x. Then you will find the limit of sine x over x multiplied by sine x over 1 plus cosine x. Okay? So the limit of sine x over x, it's 1. Here 1. Multiplied by. Then it's direct substitution, sine x, sine 0. It's 0 over 1 plus cosine 0. Cosine 0 is 1. Okay, so it will be 0 over 2, which is 0. 1 times 0 equals 0. So we reach to a conclusion, which is limit of 1 minus cosine x over x when x tends to 0 equals what? Equals 0. Let's have a look at some examples here. I want to get limit of sine 2x over tan 5x when x approaches to 0. So you write it as limit and divide the top and the bottom by x. So it will be sine 2x over x, okay, over tan 5x over x when x tends to 0. So the limit of sine 2x over x, okay, you will divide here the coefficient of the angle, which is 2. I have here 2x and I have here x. So the limit of the numerator is 2 divided by tan 5x here. It's 5x over x. So it's a 2 over 5. Here, I want to find the limit of sine x plus tan x over sine x when x tends to 0. Divide the numerator and the denominator by x. So that is going to be limit of sine x over x plus tan x over x, all divided by sine x over x when x tends to 0. So sine x over x, the limit of the first one is 1, plus tan x over x, the limit equals 1, over sine x over x is going to be 1. So 1 plus 1, 2 over 1 equals 2. Here in this example, I have limit of x cosine 3x over tan to x. So we can write it as two limits. It's limit of x over tan to x multiplied by limit of cosine 3x. Here x tends to 0 and here x tends to 0. The first one, we will divide the top and the bottom by x. So that is going to be limit of x over tan to x. You'll divide here by x at the top and x at the bottom here, multiplied by the limit of cosine 3x, 3 multiplied by 0 here. So the first limit, x divided by x, is going to be 1 over tan to x over x. We'll apply the rule, which is 2, multiplied by the limit of cosine 3 times 0, which is cosine 0. And you know, cosine 0 equals 1. So it's a half times 1, which is half. How can we find the limit of sine 3x minus 9 over 2x minus 6? You know that limit of sine x over x equals 1, and limit, let's say, sine 5x over 3x. That will be equal to what? You will divide the top and the bottom by x, so you will end up with 5 over 3, or we can write it directly. If we have here sine 5x here and here 3x, for instance, if we looked at the variable here, the variable here is x, as you see here. The variable is x here and the variable is x. So you write the coefficient of the first variable divided by the coefficient of the second variable. That will be equal to 5 over 3. So if we want to find the limit of sine, okay, 6 multiplied by x minus 8 over 11 multiplied by x minus 8. If we looked at the variable here, the variable here is x minus 8. And the variable down is x minus 8. They are the same. So in this case, you will divide 6 divided by 11 because the two variables are the same. So it will be 6 over 11. This one here, I have sine, so we can take 3 as a factor. So it will be sine 3 multiplied by x minus 3 over. We can take 2 as a factor, so it's a 2, and then here x minus 3. If we looked at the variable here, the variable is x minus 3 at the top and x minus 3 at the bottom. So what is the limit of this function? The limit is going to be what? 3 over 2. That's it. And you know that x approaches 0. So in this case, x approaches 3. Because x minus 3, the variable here, the variable, it's not x, it's x minus 3. So x minus 3 x minus 3 approaches 0, that means x approaches 3. That's it. Let's go to the next example. Here I want to get the limit of x cosine negative 2x plus 1 over x squared plus x when x approaches half. In this case, we will substitute. It's a direct substitution. Instead of x, you write half. So half cosine multiplied by negative 2 times half plus 1 over half squared plus half. So it's half cosine. Negative 2 times half plus 1, it's negative 1 plus 1, which is 0. So it's negative half cosine 0 over 1 over 4 plus half. So that is going to be half, and cosine 0 is 1 over 1 over 4 plus 1 over 2, it's 3 over 4. So half divided by 3 over 4 times 4 over 3 equals, we ended up with 2 over 3. That's it. Let's go to the next one. I want to find the limit of this function here. And I have sine squared 3x. You know, this function here can be written as its limit 1 over 5. We can take 5 down here as a factor. Okay. 1 over 5 multiplied by sine squared 3x over x squared. So we can write it as 1/5 multiplied by the limit of sine squared 3x over x squared. We can write it as sine 3x over x, all raised to the power of 2. Because sine 3x multiplied by sine 3x, it's a sine squared 3x. And x multiplied by x, it's x squared. So we have here 1/5. And we can find this limit because the variable here is x and the variable here is x. So 3 divided by 1, which is 3. 3 to the power of 2 here. So it's 1/5 multiplied by 9. 1 over 5 multiplied by 9 is going to be 9 over 5. Let's go to the next example. Don't forget multiplying by the conjugate. Okay. I have here sine x over the square root of x plus 2 minus the square root of 2. So multiply it by the conjugate. The conjugate is the square root of x plus 2 plus square root of 2 here, up and down. Okay. So that is going to be the square root of x plus 2, okay, plus the square root of 2. And we have here sine x over the square root of x plus 2 minus the square root of 2 multiplied by the conjugate. It's a conjugate. That is going to be x plus 2 minus 2. Then cancel 2 and 2. We ended up with the limit of the square root of x plus 2 plus the square root of 2 multiplied by the limit of sine x over x. When x approaches 0, so that is going to be the square root of 0 plus 2 plus the square root of 2. And here when x approaches 0, that is going to be 1 here. So square root of 2 plus square root of 2 is going to be 2 square root of 2 multiplied by 1, which is 2 square root of 2. That's it. What is the next? Sometimes we factorize. Here I have 10 of x minus 3 over x cubed minus 27. So it's 10 of x minus 3, and down we have x cubed minus 27. We are going to factorize it as difference between two cubes. So that is going to be x minus 3 multiplied by x squared plus 3x plus 9. Okay. We can write this fraction as two limits, which is the limit of 1 over x squared plus 3x plus 9 when x approaches 3 multiplied by tan of x minus 3 all divided by x minus 3 when x approaches to 3. So this one here is going to be 1 over 3 squared plus 3 times 3 plus 9 times the variable is the same as the variable at the top and at the bottom. So that is going to be 1 times 1. So it's 1 over 27 multiplied by 1, which is 1 over 27. Before you tackle this example, you know that the limit of 1 minus cosine x, 1 minus cosine x over x when x tends to 0 equals 0. And also if I said to you 1 minus cosine and it changed the angle here to 5x, so the angle down must be 5x, okay? That will be equal to 0 because I have here the same angle. I'm talking the same angle. Here 5x and here is 5x. They are the same. So we can write this limit as limit of 1 minus 3x over x here. 1 minus 3 cosine 3x. 1 minus cosine 3x over x, okay? I am going to write this one here as this 2 here as 1 minus cosine 3x and 1 minus cosine 4x. So it's 1 and 1 here. Do you know what I mean? Let's do it simply again. I'm going to write this one here, this 2 here, sorry, as 1 minus cosine 3x plus 1 minus cosine 4x over x when x tends to 0, okay? And I'm going to separate them. I'm going to write them as 2 limits. So the first limit, it's 1 minus cosine 3x over x here. So I'm going to multiply this x by 3 just to make the angle the same here. So this is the first one divided by x, and this is the second one divided by x. But to balance it, I multiplied it by 3 down to get the same angle. So multiply this limit by 3 here. Multiply by 3 at the top here. 3 at the top. And 3 at the bottom here. Okay? Plus limit. I have here 1 minus cosine 4x divided by x. So multiply it by 4 here at the bottom and multiply it by 4 at the top just to balance it. So I multiplied it by 4 to get the same angle. This angle here is 4x as you see, and this angle must be 4x. And this 4 just to balance it. So that is going to be limit of 3. We can write this 3 here in front of the limit. So 3 limit of 1 minus cosine 3x divided by 3x when x tends to 0 plus 4. We are going to write 4 in front of the limit. So that is going to be 4 multiplied by limit of 1 minus 4x cosine 4x all divided by 4x here. So it's 3 multiplied by 0. This limit is equal to 0. And plus 4 multiplied by 0. So 3 times 0 is 0 plus 4 times 0 is 0. So we ended up with 0. Before you tackle this one here, you know that sine squared of half x plus cosine squared half x equals 1. sine to the power of 2 angle plus cosine to the power of 2, the same angle equal 1. So 1 minus cosine to the power of 2 half x equals 1, equals what? Equals sine to the power of 2 half x. So I'm going to write here in this example, instead of 1 minus cosine to the power of 2 half x, I'm going to write sine to the power of 2 half x. So that is going to be limit of 4x squared over sine to the power of 2 half x. Okay? And write 4 in front of the limit multiplied by the limit of x squared here over sine squared half x. So it's 4. Then this limit here, we can write it as x divided by sine x, sine half x here. Okay? All raised to the power of 2, but if you focused on it again, here the variable is x, pay attention, and here the variable is x. The coefficient here is 1, so it's 1 here. But because x is x to the power of 2, and this sign is sine to the power of 2, so I wrote them as x over sine half x all raised to the power of 2. Then you multiply this 4 by this limit is going to be what? 1 over half to the power of 2. So 1 over half to the power of 2, it will be 1 over 4. It will be 4. So 4 times 4 equals 16. That's it. We have studied before in trigonometry that 1 plus tan squared theta equals 6 squared theta. Okay, so if you want to find 6 squared theta minus 1, that will be equal to what? Tan to the power of 2 theta. That's what I'm going to do in this example here. I have 6 squared theta minus 1, so we can substitute instead of that. We're going to write tan to the power of 2x here. Tan to the power of 2x here. Do you know why? Because 1 plus 10 to the power of 2x equals sec to the power of 2x. So sec to the power of 2x minus 1 equals 10 to the power of 2x divided by x to the power of 2 when x tends to 0. We can apply the rule here, which is 10x over x all raised to the power of 2 when x tends to 0. So that is going to be 1 raised to the power of 2, which is 1. In this example here, I have a limit of 1 minus cosine x over x squared when x tends to 0. So we are going to multiply by the conjugate, which is 1 plus cosine x, up and down, 1 plus cosine x. You know, 1 minus cosine x multiplied by 1 plus cosine x is going to be 1 minus cosine squared x, all divided by x squared multiplied by 1 plus cosine x. Okay. And you know that 1 minus cosine x from the previous examples is going to be sine squared x, all divided by x squared multiplied by 1 plus cosine x. We can write it as two limits that will be equal to limit of sine squared x divided by x squared multiplied by the limit of 1 over 1 plus cosine x. Okay, so that is going to be limit sine to the power of 2x divided by x to the power of 2, which is, we can write it as sine x over x all raised to the power of 2 multiplied by the limit of 1 over 1 plus cosine x. Okay, the first one we can apply the rule, which is 1 to the power of 2 times, and the second one we can just substitute direct substitution. Instead of x, write 0, so 1 over 1 plus cosine 0. So it's 1 times 1 over cosine 0 is 1. 1 plus 1 is 2. So it's 1 times half, which is half. Let's go to the next thing. Here in this limit, it's the same idea. We can take 4 as a factor. So it's going to be 4 multiplied by 1 minus cosine x. Okay. And we can write 4 in front of the limit. So it's 4 limit of 1 minus cosine x over sine squared 3x. Then multiplied by the conjugate, which is 1 plus cosine x at the top and at the bottom, 1 plus cosine x. So that is going to be 4 limit 1 minus cosine x multiplied by 1 plus cosine x. That is going to be 1 minus cosine squared x over sine to the power of 2 3x multiplied by 1 plus cosine x. Okay, so here 1 minus cosine to the power of 2x, that's going to be sine to the power of 2x. So write 4 as it, limit of sine to the power of 2x divided by sine to the power of 2 3x. Okay, and we can write this one here as a limit. So it's multiplied by the limit of 1 over 1 plus cosine x when x tends to 0. So that is going to be, I'm going to write here in this room. So it's 4 limit multiplied by limit sine to the power of 2x over sine to the power of 2x. We can write it as sine x over sine 3x all raised to the power of 2. Multiplied by this limit here, we are going to substitute x equals 0. So cosine 0 is 1. So that is going to be half here. And this one is going to be 4 times x sine x. The variable here is x and the variable here is x. We can apply the rule directly. Divide the coefficient of x here, which is 1, divided by 3. It's 1 over 3 to the power of 2. And that multiplied by half. So that is going to be 4 times 1 over 9 times 1 over 2. That is going to be 2 over 9. That's it. Let's go to the next question. Here in this example, I have 1 minus cosine to x over x multiplied by 10 to x. So multiply it by the conjugate. So I have here 1 minus cosine 10x over x, 10 to x. The conjugate is going to be 1 plus cosine 2x at the top and 1 plus cosine 2x at the bottom. So if we multiply them, you will get 1 minus cosine squared 2x. That is going to be divided by x 10 2x multiplied by 1 plus cosine 2x. You know 1 minus cosine 2x is going to be what? It's going to be sine squared 2x. All divided by x 10 2x. Okay. Multiplied by the limit of 1 over 1 plus cosine 2x. This one here, I have sine squared 2x. So we can write it as sine x over x multiplied by sine, sorry, it's sine 2x, not x. So we can write it as sine 2x over x multiplied by sine 2x over 10 2x multiplied by this limit here, and x approaches 0. We can just substitute x equals 0. So that is going to be 1 over 1 plus cosine 0 is 1. So that is going to be half. Okay. Sine to x over x, we can apply the rule. So that is going to be 2 times sine to x over 10 to x. This one here is going to be 2 over 2. which is 1, multiplied by half. So that cancel 2 and 2, 2 and 2, that will be equal to 1. That's it. If we looked at this one here, I have sine x over x minus pi. You know that sine pi minus x is the same as sine x. And I want to make the two variables to be the same, x minus pi here. This is the variable at the top, and this is the variable at the bottom. So we can write, instead of sine x, we can write it as pi minus x, okay, at the top, because sine pi minus x is the same as sine x divided by. Here we can take -1 as a factor. So negative, and I have here x minus pi. If we took negative as a factor, that is going to be pi minus x. Now we have the same variable. If we looked at the variable here, it's pi minus x here at the top, and pi minus x at the bottom. So you will divide the coefficient. The coefficient here is 1, and the coefficient here is -1. So that is going to be 1 divided by -1. That will be equal to -1. Let's have a look at this question here. I have tan x over x plus pi. I want to make the two variables here to be the same. So you know that tan x pi plus x, 180 plus x, it lies, this angle here lies in the third quadrant, and tan in the third quadrant is positive. So tan pi plus x is going to be tan x. So we can write, instead of tan x, we can write tan pi plus x, all divided by pi plus x. Here, the two angles are the same. So we'll divide the coefficient here by this coefficient. That is going to be 1 divided by 1, which is 1. I want to get the limit of cotan x divided by pi minus 2x. You know, 10 pi over 2 minus x. 10 pi over 2 minus x, it's 90 minus x, and 90 changes tan to cotan. So we can write, instead of cotan x, we can write tan pi over 2 minus x. The same. They are the same. Cotan x is the same as tan pi over 2 minus x. And we try to adjust it down here to make pi over 2 minus x. So if we took 2 as a factor here, 2 as a factor, so pi divided by 2 here, it's a pi over 2, and -2x divided by 2, that is going to be x. Then we have the same variable here. This variable is like this variable here. So we'll divide the coefficient by the coefficient. It's 1 at the top and 2 at the bottom. So that is going to be half. This is the last question here. Before you tackle it, I want to show you an important information we have learned before, which is sine. Sine pi over 2 plus pi over 2x. This is the angle. So pi over 2 is 90, and 90 plus this angle. So we are talking about the second quadrant. And in the second quadrant, sine is positive. But this 90 here, it changes sign to cosine. So that is going to be cosine pi over 2x. So I'm going to replace cosine pi over 2x with sine pi over 2 plus pi over 2x here. They are the same. Cosine pi over 2x is the same as sine pi over 2 plus pi over 2x. And at the top, it's 1 plus x as it. Okay? So we are going to take pi over 2 as a factor in the denominator. So that is going to be 1 plus x over sine We're going to take pi over 2 as a factor here. Sine pi over 2 as a factor. Then you are left with 1 plus x. As you see here, the two variables are the same, 1 plus x and 1 plus x. So what is the limit here? You will divide the coefficient directly by the coefficient. It's 1 over pi over 2, which is equal to 2 over pi. See you in the coming episodes. Goodbye.